Very good morning, students. Today is 13th of April 2020, and as the country is running in a reverse condition, so we don't have any option rather than save ourselves, save our country, and considering that we, the OPY educationalist, starting the online classes. Like today I am putting one of the chapter of the mathematics with the inverse trigonometrical function. Inverse trigonometrical functions. So I have put it on three words here. One is the inverse, other is the trigonometrical, other is the functions. So function is there. So we will go with the function. What is function? And in the earlier classes, class 11th, we have already gone through the relation and function. In that we have gone through what is function. But again I am repeating what is this and how it is related to the inverse trigonometrical function. So first I am making few graph like this. Let us see, this is the set A, this is the set B, and set A is having member like 1, 2, 3, set B is having member 1, 4, 9, and there is a relation like this, and F is there. So what is function? Basically function is nothing but it is the mathematical operator which operates relation between two sets. Well defined. You must say well defined, because every relation is not a function. Only those that are well defined, that's a relation. So here I put it on there. This is the well defined. F such that A to B such that Fx is equal to x square. So every member of set A is having a unique image in set B, and this is the function. So again I am repeating what is function. Function is the mathematical operator which operates well-defined relation between two sets. Here every member of the set A is having unique image in set B. I am putting another example for the definition of the function. And just see this A, B, C. This is X, Y, and Z. Again I am replicating the relation, and like this. What exactly we are seeing that every member of say A, this relation is not well defined because every member of set A is not having their unique image in set B. So this is not a function, because for function the relation and the must be well defined. Here the relation between set A and set B is not well defined. This is not a function. Again I am putting the another example. This is example number 1, this is example number 2, and this is example number 3. Suppose I am putting here Mr. X, Y, Z, and here this is a weight of these 3 persons, 1 10 kg, 10 kg, and 70 kg. I am just putting the relation like this and like this. Again here Mr. X is having the two weights. That is not practical, this is hypothetical, this is not a well-defined relation, so this is not a function. So keeping in this consideration, I am putting the definition for the function is a well-defined relation between two sets. It operates the well-defined relation between two sets. But before moving further for the target of inverse trigonometrical function, we should be aware with the which function is the category of the function and the type and the function that are having the inverse. So first of all, we'll go with the types of the function, that is types of the function. Types of the function. This is first of all one function. One function, that is injective. What is this injective function? What is this? So this is the types of the function. I am starting one of the one function, that is injective function. What is this? Basically, what is this? A function f a to b is said to be a one function if every member of set A should have unique image in set B, that is A, B, C, and 1, 2, 3. What exactly we are saying? The members of set A is having unique image in set B. So this is the function. For example, another example I am putting. Countries around the world and their capital is 1-1 relation. 1-1 relation, that is injective function. Injective function. Because every country has a particular capital that is unique. There are a few exceptions are also there, but more or less this is one of the best example for 1-1 function. The other name for 1-1 function is injective function. So this is the first type, and now further we'll proceed with the second type. This is onto function. Onto function. What is that? Onto function. A function f goes to A to B is said to be onto an onto function if every member of set B should have pre-image in set A, that is 1, 2, 3, 1, 4, 9. This is like this, A and B. As earlier we have already gone through in the 11th class that the set of member of the set A is said to be domain, and member of set B is said to be codomain. So again, I am repeating here, but one more thing we should be aware with for the onto function, that is what is range. For onto function, range should be equal to the codomain, because here, suppose I am putting like this. This is 149. Again, another I am putting 10. 149. 10 is not having any pre-image, so this is not a function. This is not a onto function, because here codomain and what is the codomain and relation between the codomain and range? Basically, range is the subset of codomain. Range is the subset of codomain. But here, this is 10. As you are saying, the range and codomain are differ, because 149 are the range and 14910 are the codomain. So range is not equal to codomain. For the onto function, range must be equal to range for onto function. For onto function, range must be equal to codomain. What exactly is that? There is a relation between the codomain and the range. The set of images basically are the range, and the part of the codomain are basically the part of the codomain is also range, but we must focus on the set of images. Basically, set of images are only the range. Now, so for onto function, codomain must be equal to range. Then we'll say that function is onto. Further, if a function is 1 as well as onto function. The other name of onto function is surjective function, surjective or surjection, surjective function. If a function is 1 as well as onto function, that is surjective function, then collectively it is said to be a bijective function. And basically, the bijective function are the invertible function. Bijective functions are invertible function. Functions. So any function that will give the inverse, there should be bijective. That function must be there. That means it should be 1 as well as onto. That is injective as well as surjective. Then only it will be the bijective function. So inverse trigonometrical function is a bijective function under a particular jurisdiction, under a particular zone, and then then only we can say that this is the invertible function. So just yes, I am starting now with the definition of the sine function, inverse sine function. How we can define the inverse sine function. So what this is basically y is equal to f of inverse x, and that's equal to sine inverse x if and only if this is x is equal to sine y, and y must be belongs to minus pi by 2 to pi by 2. What that mean? Y should rank between minus pi by 2 to pi by 2. In earlier classes also I have told you so many times, you should always work in the house. If you are not working in the house, going beyond the limit, आप घर से बाहर जाते हैं, there will be dangers. Still, you are just seeing the corona case. If people are going outside, there is risk. Same way, when you are going for the sine inverse function and you are not obeying this boundary, the boundary for the sine inverse function is minus pi by 2 to pi by 2. If you are working outside this boundary, the answer is not permissible. So we must work on this minus pi by 2 to pi by 2 only, and that is the range for that. as well as the domain for this function. Domain is -1 to 1. So domain, this is the range for the sine inverse. Domain is -1 to 1. So this is that, like this sine inverse function. And as earlier we have gone through the graphical representation of sine function. This is the sine function, y is equal to sine x, this is the sine x. And when we'll go with the inverse, that because this is keeping the inverse, so it will move like that. It will be moved like that. So this is like this. This is like that. So this is like this, and this is the pi by 2 is the and this is minus pi by 2, minus pi by 2. So the reverse is also applicable in that way. So if the reverse is like this, so when we'll convert the function, this is the y is equal to sine inverse x function. So when invertibility is there, the graph will also change, rotate like this. So it will be like this, and the judiction is like that. So whatever we work, suppose for this judiction, we should must follow in the minus pi by 2 to pi by 2. Here I am putting the example for that. This is, suppose I am writing down sine inverse, example is there, sine inverse sine 2 pi by 3. So can we write down this is straight 2 pi by 3? No, this is not 2 pi by 3. Since 2 pi by 3 does not belongs to minus pi by 2 to pi by 2. So I am not moving outside the house. Now what I will do to make it in the house, so I am doing like this, sine this is the pi minus pi by 3, can we write like this? So there will be no effect in the either we are writing the sine 2 pi by 3 or sine pi by, but in that case I am trying to put the function inside the house. This is the sine pi by 3 we can write down, and now pi by 3 will be the answer. This both will be cancelled, pi by 3. Since pi by 3 belongs to minus pi by 2 to pi by 2. So what exactly I want to convey you people? You should must play in the house, around the house. If you are doing the work, that is not permissible. Anytime, whenever, wherever you are having this function or the sine inverse function, you should must keep inside the house. If not, it will not be workable. If it is in not house, put in the house and then work. Same way, we can go for the definition for inverse cosine function. Inverse, next is inverse cosine function. Inverse cosine function. What is this and how we can go for? The y is equal to f of inverse x is equal to cos inverse x. Then if x is equal to cos of y and y must belongs to 0 to pi. Here the house is 0 to pi. So when we have gone through, earlier we have gone through the graphical representation of cosine function like this. This is the y is equal to cos x. But for y is equal to cos inverse x, what is this? The graph will be like this. So this is like a pi, this is the pi, and exactly it is like this. So this is 0, and this is like this. The graph will be like that, and this is the 1, and this is the pi. This is the pi, and you can say like that. This is the pi, and this is the pi by 2. So from 0, this is the 0 to that. So this is the house. Because the sending capacity for this group is not too much, so I'm just putting down here only saying all of you must go through the inverse function, and one of the category of the function we have mentioned here, that is sine inverse function, and more or less we have also made that the cosine function. So you just go through both the function. Apart from that, I'm also attaching the revision chapter for for your purpose of the previous chapters as matrices determinant and the stage 2 of the matrices. I'm just putting few of the questions like for IIT level, IIT mains level, as well as the CBSC level. So time to time, I will try to send these questions from the different sections, some different category. Hot questions also I will try to send, and definitely it will work able for your purpose. Thank you. God bless you for today.